We have a series of speakers over the next 45 minutes, and the first one I am absolutely delighted. One of the kings of astronomy, we use that now. Donald Trump is my new mantra for how we move forward. One of the kings of astronomy, Professor Fred Watson, and he's going to be talking about dark skies down under.
Thank you very much. Yes, I've got a mic as well. Thank you very much, Teresa. So this talk has a subtitle which is not as advertised. It's what keeps astronomers awake at night. Because I'm going to talk to you, apart from astronomy, of course, I'm going to talk to you about regulation. You'll love this. Regulation, not astronomy, but you'll see how it feeds into astronomy. That's me. As I mentioned this morning, I'm no longer the astronomer at large. That job came to an end in December, but I do have some street cred at Macquarie University. And if all else fails, Marnie Ogg is my boss. Because I do things for Dark Sky Traveller. So, trilogy in 4 parts. I want to talk a little bit about where we are and why we do astronomy here. I want to talk about the radio sky, which is part of dark and quiet skies and has lessons for us, I think, in visible light astronomy, how we protect our observatories, and then really the kernel of the talk, which is where it all goes pear-shaped, but we'll get to that in a few minutes. So let me just talk about our vantage point on the sky, and this is a nice shot of the Palm Beach Lighthouse, which is now part of an urban dark sky park, as I'm sure you would know. We have numerous advantages here in Australia. The latitude advantage, our latitude gives us access to the most important parts of the celestial sphere, the southern sky, the galactic center, the 2 nearest dwarf galaxies, the 2 brightest globular clusters, all of the above. Likewise, we have a longitude advantage because we sit between southern Africa and South America, so anything that needs 24/7 coverage needs to be observed from Australia as the Earth rotates. We have stable atmospheric conditions. There are places in the world where it's more stable, and I'll get to that in a minute, but it's pretty good here. And dark skies, as we've heard already. And in fact, turning again to radio astronomy, probably the most radio quiet site on land anyway on Earth. This is a map of our country, just marking a few of the observatories that are protected by legislation. The red dots are all radio telescopes, radio observatories. And these are the main ones. That's not complete. The one blue place there is Siding Spring Observatory, which you heard about or some of you heard about when Chris Lidman gave his talk earlier this afternoon. That is an optical observatory. There are a number of others that come under the auspices of nominated sites for astronomy, but they're not actually protected by legislation. So let's just talk briefly about radio astronomy first. We have this suite of radio facilities in our country. It spans the continent from Parkes, which is also known as Murray-Yang, in the east on Wiradjuri country, to over in the west. A very different environment, the CSIRO Murchison Radio Astronomy Observatory in Yarimana, Ilgari Bundara, which is a Wiradjuri name meaning sky, sharing sky and stars. That is the site of a number of radio facilities, but it's the home of the future low-frequency component of the International Square Kilometre Array, which will look like that. And those of you who are tuned into this kind of thing will know that the first 1,074 antennas were brought into use recently and hit the headlines yesterday with some images taken with the first part of the Square Kilometre Array. That completion date has now been pushed back. It says 2028. It's more likely to be 2030. I have a vested interest in this telescope because at one point, a few years ago, I had to front up to a parliamentary committee and I gave them my personal guarantee that this will win Nobel Prizes. So I'm encouraging everybody to get on with it and win the prizes. It is legislated to be radio silent out to 260 kilometers away. And this is just a snapshot of what that legislation looks like. I'm not going to go through it. There's 5 different layers of protection. It is unprecedented, as I said in that previous slide. These are all the agencies and the different regulations that protect its radio quiet sky. And then to the optical field, optical astronomy, the flagship site is Siding Spring Observatory. in Gamilaroi country, in the Warrumbungle Mountains. Warrumbungle is a Gamilaroi word meaning crooked mountains, which you've only to look at to realize that's what it is. That dome that you can see there, the dome of the Anglo-Australian Telescope, the largest visible light telescope on Australian soil, still, as I've said there, doing world-class science. I'm not just saying that because I was its astronomer in charge for 20 years. I often tell people that I worked for so many years in that building that I started to look like it. And without the ribbon there. The ribbon, by the way, was Marnie's idea for the 40th anniversary. That ribbon is around the upper walkway of the telescope. Some of you will have heard Chris Lidman's talk this afternoon. Chris has been director there since 2018, and he was telling me this morning his hairstyle is going the same way. Are you here, Chris? And I thought, well, you've got a bit further than I have to go, Chris, before you look like me. But anyway, Chris is doing an extraordinary job. The telescope itself, I don't need to show you pictures, probably the biggest optical instrument in the country, owned actually by the Commonwealth still, but operated by the ANU. And the site is, again, protected by legislation. We celebrated its 50th birthday last year. It was opened by a gentleman who signed his name Charles in the visitor's book in 1974, and he wrote to us last year to say, good work, everybody, something like that. He's now the king, of course. Why do astronomers need dark skies? Because, as you can see from this image, taken by Angel Lopez Sanchez, a very prolific astrophotographer at Macquarie University, you can see that the sky itself is luminous. The unpolluted night sky is luminous. These trees and the water tower there are silhouetted black against it. Sometimes astronomers are looking at objects whose brightness is only 1 or 2% brighter than that night sky background. So you can imagine as soon as you put any light pollution in there, your objects disappear altogether. And that's why you need dark skies. And as Chris said, and I won't go through this, it is protected by New South Wales state legislation. We also have lighting standards that help to protect it. The Warrumbungle Dark Sky Park, we heard all about that this afternoon. And the other dark sky places in Australia, which we heard about. And I might mention that the observatory still collaborates very closely with the Australasian Dark Sky Alliance. The thing about optical astronomy is you need not just dark skies, but absolutely exquisite atmospheric stability. You need an atmosphere which is completely free of turbulence. And we don't have that in Australia. For all that Siding Spring is probably the best observing site in the country for visible light or optical astronomy, it's not perfect. And if you want perfection, you've got to go to just a handful of places in the world. And the best in the southern hemisphere is on top of a couple of mountain peaks in northern Chile. And there are telescopes there which are run by the European Southern Observatory, with which we in Australia have a strategic partnership, which actually runs out in a couple of years. That strategic partnership means that this is part of the Australian astronomers' suite of instruments. And they are indeed the world's finest telescopes. Those four enclosures together are known as the VLT, the Very Large Telescope. And they also have indigenous names in the Mapuche language, Antukuyan, Melipal, and Yepun, which means sun, moon, Southern Cross, and morning star. So that is what Australian astronomers have access to. That site is also protected, as is a large site next door where this is being built. This is the ELT, the Extremely Large Telescope, 39.3 meters in diameter, exactly 10 times bigger than the Anglo-Australian Telescope. We hope to have membership of this consortium that is building that, but the problem is it's very expensive. This telescope is now half finished. This photograph was taken last month. That sort of lattice work that you can see down at the bottom is where the main mirror will be supported. It consists of 798 hexagonal segments about this size, and together they make that 39-meter mirror. Despite the protection that this observatory site has, and it's about 20 kilometers from Cerro Paranal, where the VLT is, it's already under threat. There is a proposed green hydrogen plant being built or being planned between them. And about 1,000, no, it's now more than 2,000 astronomers worldwide, including me, have signed a petition asking for this to be revised because it's a bad idea. So that's how our terrestrial telescopes, our land-based telescopes, are protected. And what they're protected from, apart from the green hydrogen plant yet, is in fact terrestrial light pollution. But of course, that's not all we have to cope with, because in May 2019, this happened. Very famous footage of the first of these satellite trains, which represented the start of the Starlink constellation, which certainly shocked the world of astronomy. I've headed that, the end of astronomy, which is slightly tongue-in-cheek. However, that's what the Starlink constellation looks like, not today, but 2 days ago. 10 minutes, thank you very much. That's great. Thanks, Teresa. The number of satellites that are just simply over Australia there is quite phenomenal. It's, many tens. And worldwide, there are 775 which are in orbit. That's not the total that have been launched. There's about 1,000 that have already re-entered. These satellites only have a lifetime of 5 years, so they've already re-entered. But the bottom line is that Australian astronomers share the global challenge of interference from these constellations, and it affects all sky watchers. We heard some questions about that this morning when the panel was sitting up here, how First Nations traditions and things of that sort, as well as astronomical observation, are affected. And it doesn't matter how much you legislate against terrestrial light pollution, that doesn't affect this at all. It's a separate issue. There are some statistics which you might find entertaining, including the planned satellite number. This is just mega constellations that we're talking about. Don't worry too much about that 500,000 planned satellites, because I'll come to that in a minute. But the bottom line is there's a lot of them, and the number is growing. Why are they a problem? We see them in twilight, when the sun has set on the surface of the Earth, but the spacecraft is still illuminated by the sun. But of course, in the radio sky, they're visible all the time, because they're continuously transmitting down to Earth. So this is a problem for radio astronomers. That's the graph that actually Pete referred to this morning, the fact that it's an exponential rise. That is, day before yesterday, total number of active satellites. That includes Starlink, as well as the geostationary satellites and a lot of other stuff like GPS and other communications, 11,219. So the statistics look like this. Starlink's got 12,000 approved in this present generation, of which 7,075, as you just saw, are already operational. They can launch up to 106 or thereabouts a month. There is Generation 2, which is approved to produce another 30,000. So Starlink could be 42,000 spacecraft. OneWeb you might have heard of. It's a UK-led consortium, 648, so it doesn't actually count as a mega constellation. And as I'll mention in a minute, they are different. Kuiper is about 3,000, that's still proposed. But these are the ones that worry us in the world of astronomy. The two major Chinese mega constellations, one of 14,000 and one of 13,000 satellites, which have already started being launched. And as I'll mention in a minute, again, particularly the Qianfan spacecraft, they are very bright in the night sky. And there was a proposal in 2021 by the Rwandan government to launch over 300,000 satellites, of which none have been launched, so they'll probably lose their slot in 2028. I think the allocations last for about 7 years. So what's the demand for all this? Well, it's high-speed internet. And there's a number of things that have led to it. Technology, of course, SpaceX has brought down the price of putting things into orbit by the fact that they can land their boosters, their first-stage boosters, on a barge like this and bring them back for reuse. I think the record so far is one of them. These are Falcon 9 boosters. I think 26 times is the maximum number that one has been used. And that is incredible in bringing down the cost, because you're not throwing away the goods. But then there's the demand for high-speed internet. Everybody wants instantaneous internet. And as I've said there, it's been stimulated actually by COVID. Gaming helped a lot. People want instantaneous gaming connections with their friends overseas. The war has also done that. But the point I make there is that it's so much better, so much more instantaneous than geostationary communication. SkyMuster is one of the NBN geostationary satellites. It takes 665 milliseconds to get a signal up and back, compared with 30 milliseconds for Starlink. And then the filings with the International Telecommunications Union are very easily obtained. That's the only international body that regulates launches, but with no regulations about orbital congestion. And then it's the individual national regulators that have to sign off. A comment by a person who is now actually the Secretary General of UNOOSA, the UN Office of Outer Space Affairs. Take them with a pinch of salt. And she said that because the industry itself is worried about this congestion because of the risk of collision. You might get a Kessler syndrome situation where it's like a house of cards, everything falls down. Maybe future generations will be more efficient, so you need fewer spacecraft. That's hard to imagine, but we still think that by the end of the decade, there'll probably be 100,000 satellites with about 5,000 above the horizon at any one time. This image, again, of Starlink satellites just after they've been launched. The industry, parts of the industry, and SpaceX are certainly in this category, parts of the industry are engaged with astronomers. And they have done a lot of work at SpaceX to try and reduce the brightness of the satellites once they're in their orbital station. Because that's an important thing to do. If you can get them below naked eye visibility, first of all, you make it easier for professional astronomers to deal with them, but you also mean that people don't actually see them. As I've said, they've worked on that. OneWeb, they're too faint already because they're 1,200 kilometers high. But the Qianfan satellites, as I've said, are much brighter. We don't know what the Chinese are doing in the way of mitigation. There's new threats as well. Bluebird is the brightest object in the night sky, or the brightest artificial object, after the International Space Station. D2M services, that is direct to mobile. There's a whole area of work on how we can put satellites in low Earth orbit that give us direct signals to mobile, and they're a complete unknown. For visible light astronomers, it's the wide field telescopes like this one, which will open up later in the year, the Charles Simonyi telescope, again in Chile. They're worst affected, and the astrophotographers know this. They have really difficult problems getting these satellite trails out of their photographs. Let me just go back to that. 8% of images from the Hubble telescope are affected. I'll ignore the talk about potentially hazardous asteroids because I don't have time to describe it. But the bottom line for Australian astronomers, thank you very much, Teresa, we're less affected because we don't do much imaging. It's mostly spectroscopic, where you're analyzing the light. Radio astronomers actually have got the worst of all worlds because they work in a spectrum of radio signals which has just tiny little gaps in it for the astronomers to work in. Everything else is broadcast or telemetry or whatever. And so it is that the crowded spectrum is the first of their problems. Day and night interference. I won't go into the details of this because we're a visible light group, but some of the things are quite interesting, like the satellites themselves are noisy. Before they even start broadcasting down, they're noisy. Their electronics are noisy and can be picked up by radio telescope dishes. There are some unbelievably, some are unregistered, but you also can get reflection from satellites, giving you FM signals coming from Perth, for example, in Western Australia. What are astronomers doing? Well, they did a lot of grumbling to start with, and that's a picture of a grumbling astronomer there. That was at a conference in La Palma 2 years ago, which was one of a very large number of conferences that we've had. We've produced a very large number of technical papers, draft submissions to United Nations Committee on the Peaceful Uses of Outer Space, raising the issue at these similar fora. COPUOS is a very important forum. Actually, they had success this time. This was February when this happened, and the issue of dark and quiet skies is now on the COPUOS agenda, which sounds like a small step, but it's actually quite a big step to get that recognized by this group. And there is also a United Nations group of friends on the issue, which is actually a technical term used in the UN. Australia is not yet a member of that. I asked one of my colleagues by email yesterday, the day before yesterday, whether it was, and she said, I can't answer that, which I think means they're still thinking about it. But Australia does support the efforts of the industry and the astronomical community, and as I've said there, engages with the UN committee there. It is engaging. That's me, my only time at the UN in Vienna, reading our position out. The IAU Centre, which was formed in 2022, nearly finished, is an excellent source of interaction between the industry and the astronomers. There's agreements like NSF and SpaceX. CSIRO is also involved with that. Finally, effectively the last slide, last but nearly. What do we want? Moderate change. When do we want it? In due course. Minimize the numbers, operate them below 600 kilometers. Starlink did that. Avoid directly illuminating radio observatories, comply with the signal strengths, better regulation, providing accurate positions, and there are strategies in place now to try and avoid that. I'm reluctant to end this talk on a down note because I think there's a positive to come from it, which is opportunities for outreach. People see these things, they've no idea what they are, they want to know, and when you tell them, they quite quickly understand it. And so I think there is, with education too, an opportunity to capitalize on these mega constellations. Astronomy won't be the same. It's changing, there's no question about that. But dark and quiet locations do remain vitally important to us all. And that is the end of my talk, which I've overshot, so there you are. Thank you very much. Teresa.
They've cut me off. Oh no, I'm on. It's very difficult to pull someone like Fred off the stage, but thank you. That was an amazing talk. We don't have time for a question, I'm afraid, but I'm assuming, Fred, you're going to be around. If people have any questions, then please find him. Yes.